Hello, ladies and gentlemen. I hope you've had a great weekend. But now we're jumping back into it. Real quick, two things. Number one, what we've got going on this week. So today and tomorrow, we're going to talk about functional groups and finish all that up. Then on Wednesday, we're going to do a quick review and then a quiz. And then on Thursday and Friday, we're going to start our exam review. And then we're going to continue that on next week. So, speaking of the final exam, um, I've never been one to think that it makes sense to make your 20% of your grade count from one day's assignment. That's a little wacky to me. So I usually weight my final exam similar to a test, maybe even two tests, depending on what it is. Since we're stuck online, really what we're going to do for the final exam is just going to be a test on the organic chemistry stuff we've done. Um, so in the alkanes, alkenes, alkynes, drawing the structures and the names, and then the functional group section we're doing right now. So we'll review all that, and I'll let you know more specifics as we get closer. But for now, let's jump back into functional groups. So, functional groups, day 3. Yesterday we talked about halides, ethers, and alcohols. I believe that was all it was. So today we're going to start with aldehydes. So an aldehyde is also something we're going to call an end carbonyl. Okay, a carbonyl group is something different. So a carbonyl group, you see carb, so you can guess that has to do with carbon, right? You even see the word carbon in there. A carbonyl group is literally just a oxygen double bonded to a carbon. So anytime you see an oxygen double bonded to a carbon, that together, that's just called a carbonyl group. Now, these aldehydes are used in anything from tanning beds to making glue to photography to administering drug tests. This stuff is surprisingly versatile. It's used in a million different things. Um, and to show you an example of it, if you have any carbon chain, and on the end carbon, so one of this one or this one, not the one in the middle, one of the ones on the end, if the one on the end is double bonded to an oxygen, then, uh-oh, I reorganized and I don't know where my highlighter is. This is so sad. Looks like we're using green today. So this section tells us that we are going to be a aldehyde because there's the end carbon double bonded to an oxygen. And this one is called propanol. Why? Prop, because how many carbons do we have? 3. And al, right? Remember, last week we distinguished there was all and al, and I said I was going to pronounce this one differently. The al comes from the al in aldehyde. All right. So next one I have today is what is a ketone? These two are usually grouped together. A ketone is also something we call a middle carbonyl. Okay, so an end carbonyl meant it was on the end carbon, so don't think this would be too much of a surprise. This is going to be one where the oxygen is attached to a carbon that is not on the end. So for this example, the carbon right here in the middle. This specific example is what we call acetone, which I'm sure before you guys pieced out with Miss Moog, you used a lot in the labs. Acetone is probably one of the most common substances used in chemistry. It's just a really good solvent. And the name of this would be propanane, or no, I'm sorry, propanone. That's an O-N-E. Why? Because we have 3 carbons, which gives us prop. One comes from ketone, and that's that. So next we have something called an ester, aka what I'd call a yum, because esters are actually the chemical that end up giving fruit and flowers their tastes and smells. If you've ever tasted banana or smelled banana, you are actually tasting and smelling an organic compound called an ester. Um, what esters look like is a chunk that looks like this. It's a little more complex than the other ones we've talked about, but it's always marked by a carbon that's double bonded with an oxygen and single bonded with another oxygen, where the single bonded oxygen keeps going with carbons. Kind of weird, and you're probably going to need to look at the other examples. In fact, you're going to have to. It's going to be on page 747, or I'm sorry, 474. You'll need that later. Now, this is all well and good, but until we see it in an equation, it's going to be kind of hard to actually understand that. So let's look at one of my favorites, which is this guy. Um, really, really long boy right here. So first things first, can we find our friend here? A carbon that's double bonded to an oxygen, single bonded to an oxygen. Well, here's a carbon that's double bonded to an oxygen and single bonded to an oxygen. Now, does the oxygen keep going with carbons? Yes, he does. Then it looks like this is an ester group. Okay? So, how would we name this sucker? So what's the longest chain of carbons? Here I have carbon-carbon, that's 2. That would be eth. It's not the longest. Here I have 1, 2, 3, 4, 5. 5 long, that would be pent. So I know I have pent in the name. And I have a chain of 2 carbons, so I'm also going to have eth somewhere. So I've got pent and I've got eth. Now, the prefix for one of these esters is kind of weird, and it's O8. I think we wrote that down in our little prefix page earlier. So the O8 would go with the busiest side. Is the chunky buddy here on the left, further to the left or further to the right? Closer to the left. So I've got the 2 carbons here, the eth. So this would become ethanoate. And then for this pent, I'm going to throw in a YL, pentyl. Pentyl ethanoate. Hey, fantastic. And this is the flavor of banana. This is the chemical that gives banana its smell and its taste. So what I want you guys to do on page 474 is, um, I wrote down the one from banana. There are 3 other ones. Please make sure those 3 get into your notes. And wonder of wonders, miracle of miracles, doing that is all I have for you for homework today. Um, so just make sure those other 3 get in your notes from that table on page 474. Make sure these notes get to me, and I will consider that homework for today. If you have any questions about anything, please let me know. If I were you, I would recommend using your time you're not doing homework today to look over the stuff from last week, especially the naming and stuff, so you can be more familiar with that for the quiz Wednesday. But with that being said, hope you guys have a wonderful rest of your Monday. Bye.